our bring back to our give your announcement by we finish test number 1. Okay. Now, is there going to be a tutorial this Friday, Taylor? Yes, there'll be a tutorial this Friday. Okay. Any other questions? There is reading week. Okay, if you look reading week, Brandon is week 7. I put in from February 21st to 25th. We have nothing. It's reading week. Okay, Brandon. Any other question before we start? I don't hear anything. Okay. Then average of this class last term was D plus. Okay, that is the average of this class. Okay. Now this class you have to have. Can someone tell me where did Dr. Koshi teach you guys until a D for delta plus? Okay. Can someone tell me where you all were taught up to at 2P04? What was the last chapter? Can someone tell me, please? Anyone? What do you last learn? Hello? Oh, you all learn combined loading. Dr. Start of sharing stress. Rest in peace. Sharing stress. Hey, listen. Okay. It's going to be a fair test. Okay. I'm always improving. So what happened last term and this term might not be the same. Okay, this term you guys might be more hardworking than last term, or might be the other way. Okay, so the class average might be a D minus. Okay, but you need to put time and effort in this course. Okay, okay. Let me tell you before I go on. Let me explain to you what is the difference with this course. Okay, so in 2P04. Okay, when Dr. Koshi was teaching you guys, there is a lot of remembering of concept. There is a lot on understanding of the concept. Okay. So you guys I think you guys were taught bending moments. You guys were taught 3D stress analysis, so on and so forth. It's just remembering and understanding. And remembering, I think there's quite a bit of procedure. Okay, this is for 2P04. And you have maybe just a bit of analysis. Okay, just a bit of analysis. So if I'm going to look at 2P, a lot of times you will spend about 40% of the time remembering, 40% on understanding, 20% on analysis. Okay, so this is the overall structure in terms of learning. Okay, 3A03. Okay, you still have components of remember, understanding, analysis, apply, and critic. So I test you on more component, okay? Remembering will be maybe 10%-ish. Understanding will be about 30%, okay? Analysis will be about 20%, okay? Apply will be about 20%. Okay, so that is, this is how many already? 30, 50, 20, 10, and another 20% to critic. Okay, the further you go up the line, okay, it's going to be more difficult. It's well known. Okay, so the difficulty goes up. Okay, when we go further in terms of learning. Remembering and understanding, analysis, apply, and critique are all a learning process. Okay, so it's going to get more difficult. Okay, so that's why the class average is low. But listen, I'm not really bothered with your class average. More important, I want you to learn, and I'm going to do something different this term. I will only disclose after your first term test. Okay, I can tell you now. If I tell you now, everyone will take it easy. Let's not short for class. Okay, any other questions? Okay, no, I will start the class. Okay, I will do our introduction. You guys don't hear the squeaky pen anymore. Okay, so I posted these notes on Avenue to Learn, or not these notes, this table on Avenue to Learn. So a lot of times you all can see the table now, right? Okay, what we see down here is a material property table. Okay, so you have steel on the first column is the material type, steel, cast iron, aluminum. Okay, go on and so forth. It's on your textbook. Given density. Then the first column is ultimate strength. If you look at the ultimate strength, it's divided into tensile, compression, and shear. Okay, so that's ultimate strength. The yield, again, you have in tension, and then you have in shear. Okay, then you have modulus of elasticity, and then you have modulus of rigidity. Okay, and then you have coefficient of thermal expansion and ductility. Now, can someone tell me why do they give ultimate strength and yield strength? Can someone tell me why? Anyone? Anyone? Why do they give both, and which one would you use? Anyone? I hear no answer. Everyone is still shy. Good morning. Okay. Before I go any further, I will show you a table, if I may. And this is the textbook, okay, that we'll be using. And we are going to look at this formula over here on chapter number 1, and probably you guys have seen it before. Okay, this one over here. Okay. Yeah, and I'm going to copy. Okay. And I'm going to, okay, all of a sudden my OneNote gone missing. Unbelievable. No, it's there. Okay. And I'm going to paste over here. So what you can see over here is we have a formula that states that the factor of safety is equal to what? The ultimate stress divided by the allowable stress. Okay. To determine if the structure is safe, okay? The caffeine hasn't kicked in yet. Good morning, mine's whiskey, okay? I need it. Eric, since you are there, I would like to talk to you after class. I need your feedback regarding an issue. Eric signage, okay? Right. So here, so the factor of safety is ultimate stress divided by allowable stress, right? That's given on a table. So if I were to recall you on drawing the infamous stress strain curve, you guys say, oh shit, here we go again. Okay, if we look at our stress strain curve. Okay. So so this is strain. This is stress. Okay. So initially you're going to see a linear relationship, right? And then you will see from here, you have this. Okay, so over here, this is your ultimate strength. Then over here at this point, that is our U strength. Okay, and as what I said, as you have seen this diagram countless time on 3CO3, if we were to draw a line down here, okay, on the right hand side is the plastic region. This is where we have the Johnson-Cook equation, okay, and then on the left hand side is the elastic region. Okay, so on the right hand side, you apply for McCann 3CO3. Okay, on the right hand side, because when you do manufacturing, you want your material to be in the plastic region. Okay, you want your material to be an elastic region. Okay, on the left hand side is where you have topics like 2PO4 and 3AO3. Okay, you want to design something that operate in the elastic region and not in the plastic region. Okay, so now going back to the formula at the top. Okay, now we look at the formula at the top. Okay, the formula at the top say factor of safety is equal to ultimate stress divided by allowable stress. Can someone give me an opinion regarding this matter, please? What do you think? Is the formula right or is the formula wrong? And if it's right, tell me why. If it's wrong, tell me why. Anyone, please. You cannot just take it for a fact that this is from the textbook. We are good to go. I'm not saying that the textbook is wrong, okay? But can anyone make a comment, please? Anyone? Jason, you are definitely right, man. If we use the ultimate strength, okay, it's true the allowable stress can go into the plastic region. You are absolutely right. Okay. So this is where I bring us back into here. This is where we go deeper into application and to be critical about our application. Okay, in 2PO4, they just give you a set of formula. Okay, this is the textbook, go. Okay, factor of safety is equal to ultimate strength divided by allowable ultimate stress divided by allowable stress. Okay, okay, let me tell you what is correct now. Okay, or let me tell you what's going on now. Okay, so let's go into we apply now. Okay, let's look into apply. Okay, let's look at apply. Okay, so the factor of safety formula is dependent on material behavior. Behavior over here is dependent whether are they classified as brittle